Alright, let's talk about fractured static meshes. Fractured static meshes allow you to add some more interactivity to your levels by taking something which generally doesn't move, like a static mesh, and giving you the ability to blow it to tiny bits while you play your game. Now, let's take a look at one of these. I've got a fractured static mesh set up here in this level. I'm just going to drop in. Now, all these exterior walls, these are just regular static meshes. I can shoot them, and nothing happens. It's pretty much what we expect from static meshes. However, this wall breaks apart. I can blow a hole through it. This is what fractured static meshes are all about. They're very easy to set up, but they do have a few properties you need to be aware of. The other thing is that when you want to create your own fractured static mesh, you need to use a static mesh that has a collision model, because that collision model is what actually is going to be used to calculate the fracture. So please keep that in mind as kind of our opening guideline. Now I'm going to jump out of this level, and let's set up a really basic fracture of our own, and then we'll come back and we'll talk in a little bit more depth about the properties that we're using. So for starters, let's just open up the content browser. I'm going to switch to all assets, clear out my search line, and what I want you to do is search for supports. So supports, and then let's narrow this down to just static meshes. And we see SHU supports SM Cement Block 01, which if we double click it to open it up in the static mesh editor, it's already a nice big block of cement, which looks like it's ready to be shattered. I mean, it's just crying out for us to just bust it into tiny bits. So what we're going to do is, with this guy opened up here inside the static mesh editor, we're going to click on the fracture tool button. It's located right next to the save thumbnail angle, which is a little eyeball. It's a little faint yellow wireframe. Another option, you can go under the tool menu of the static mesh editor and choose fracture tool. Now this will open up the fracture tool window, which has a few sliders, a few entry fields, and some checkboxes and whatnot. We're going to leave most of this alone. We're not really going to dwell on that right now, but I am going to kind of position our static mesh editor so we can see the fracture tool at the same time. Let's just set some very general properties to get a basic fracture going on, and then in a future video we'll go into some more depth on what you see here. So I'm going to start off with my generate trunks group. We're going to take the num chunk slider and slide it up to something like 50 chunks. As soon as we do that, I'm going to click generate, and check it out. Over here in the static mesh editor, we can actually see a representation of these chunks. Now, if you want to see them a little more easily, you can scroll down here to show cuts solid and check that, and now you can get a clearer idea of exactly how many cuts there are. Now, without going too far into what you're doing, you can click on any one of these chunks and you'll get some feedback. These numbers you see are representative of how much of a connection that chunk has to all of its neighboring pieces. So a greater number means it's actually touching more of the surface of a neighboring piece. What I'm going to do, though, is come back over here to the fracture tool window, and down in the chunk selection group, you see select bottom. I'm going to click on that, and that's a good enough selection for my purposes. Actually, let me make sure that nothing is selected first. Then I'm going to click select bottom, because I don't want that chunk up there to be selected. Now, with just the bottom selected, I'm going to switch off destroyable. That means that the chunks down here on the bottom will not be able to be broken away, but I will switch on support chunk. That means these chunks will kind of help hold the overall integrity of our fractured mesh together. Now, currently we need to slice this. We need to kind of finalize our chunks. You'll notice that over here inside the static mesh editor, you see 50 chunks, but need slicing. So let's go ahead and click slice. We'll get a little bit of a calculation. And then it's going to ask for some package info. Let's store this in fracture mesh demo as a package. Group, we'll just call the group meshes. And then I don't really want to use this really big long name. I mean, we could, but we're going to call this fractured underscore column and click OK. It generates everything that it needs to. And there we go, we're done. We can now close out of the fracture tool, though before we do, take a look at our mesh. Notice it went back to 50 chunks, but the tool said, the mesh went down to 49 chunks, though the tool says 50 chunks. The reason for that is that one of those chunks was entirely inside the mesh and no part of its surface actually touched the outside that the player sees. Any chunk that is completely contained like that will get culled away and it won't calculate. So let's go ahead and close the fracture tool. I'm going to close the static mesh editor as well. And we need to find this package. Now, if you scroll over here in your source area and you don't see the package you just created, a quick way to show it up is to come to the top of your content browser. There's this little tiny drop-down arrow, and you can choose full refresh. Alternatively, you can hit Control F5. And now we can see the Fracture Static Meshes package. Let's go ahead and hit Control S and save that. So Control S. Oh, can't save map files, not saving it just yet. Okay, we won't worry about that yet. Let me go ahead and clear out the filter area. Make sure we're inside of Fracture Mesh Demo. There we go. And we'll hit Control S, click Save. Now, there's our fractured column mesh. Our package is saved. All we need to do is get this placed in our level. So I'm just going to drag and drop right out of the content browser, like so. Now, it's crucial that we build lighting. And something that is going to kind of pop up a little later, though I will go ahead and start reminding you of it now. Every change that we make to the settings of a fractured static mesh will require that lighting gets rebuilt. So keep that in mind and make sure you're done editing your fractured static mesh before you build lighting. But I'm going to slide our lighting kind of off here to the side. We'll take just a moment and build it, which shouldn't take long with such a simple level. And here it goes, and light mass is doing its thing. Go, light mass, go! And as soon as this is done, we'll jump into the level and just see how this is working. So that's all finished. We can close out our arrow windows. Let's right-click and choose Play from here. And here's our great big column like a monolith. And if we shoot it, pieces are breaking off, which is excellent. Now currently, you'll notice we have the null material on the inner surfaces. That's something we can clean up in the properties of the fractured static mesh, so that's not really all that important to us. But we have set up a basic fracture, and that's going to wrap things up for this video. As we move forward, we'll talk more about these settings and how we can exert a little more control over our fracture mesh. For now, go ahead and save your level, and then we'll move forward. Thanks. In this video, all I really want to do is give you an overview of the key properties and settings of the Fracture tool window. So I'm going to jump into the content browser. I'll open up our fractured static mesh, and then immediately jump into the Fracture tool here from the Static Mesh Editor's toolbar. Now let's just kind of start at the top and work our way down. Most of these are fairly straightforward. Some of them may take a little bit of explanation to really wrap your head around, but at the very top, we have the Generate Chunks group, which has the num chunk slider. This tells you really how many chunks you're going to get. That's really all there is to it. If you want more chunks, slide it to the right. If you want less chunks, slide to the left. Do keep in mind that the more chunks your object has, the more expensive it's going to be in terms of calculation. Now down from here, we have the chunk shape. This allows you to influence the overall shape of your chunks by applying a bias to the internal clipping planes that are cutting up your object. For instance, right now, with an equal bias of 1 in X, Y, and Z, which is what these three fields represent, we get these fairly uniform chunks that you see here. As a matter of fact, to make them real easy to see, let's go ahead and click Show Cut Solid. So they're all fairly square. Some are longer than others, but overall, generally uniform. If we want these to be more longish, like say we really want some elongated splits, we could take our X and Y and set those down to 0.1. So I'm just going to 0.1 and 0.1. So now check it out. The Z direction, which is our vertical direction, is getting more of a bias. So our chunks are a lot longer in their overall width. We're getting a whole bunch of flat chunks. And by changing the overall bias of these planes, you can change the shape of your chunks. That's really all there is to it. Now I'm going to set these all back to their default 0.1 values. Now you can also modify the points of a chunk, and this is something that you kind of need. There's two separate ways to go about this. We can select a single chunk, and you'll notice when we select a chunk, like let's grab this guy up here at the corner, we get a little translation widget up here near the top. as well as all these different numbers. Now, as I mentioned in the previous video, these numbers represent how connected or how much of the surface is touching each neighboring piece. However, there's also this little tiny transform widget, and as I slide this, we can literally update the shape of that chunk. So you'll notice as I slide it to the right, more of the influence for that chunk is sliding rightward. So you have a lot of control here. And what I'm doing is I'm moving the chunk's origin, which is kind of like its center of positioning for how the chunk is calculated. Now that brings us back to the modify points group. What this allows us to do is to move around the origins of all of these selected chunks at once. Or if we deselect, we can actually do it to everybody. So if I click randomize, you'll notice there's a slight shift in all of our chunks. That's because right now, all of those origins are being moved in a random direction by a random amount around 0.1 in X, Y, and Z. If we want a lot of motion, we can set this a lot higher, say to 10 by 10 by 10, and click randomize. And now you'll notice you get much more vast changes in the overall look of your chunks. Now, if you want, you can also click Move to Faces. What this is going to do is take those origins and slide them out to the outer edges of your surface. This will help keep you from having too many chunks that disappear because they're completely internal to the mesh. Now, I'm just going to re-click Generate and put everything kind of back to its general positioning. Now, next we have chunk options. For this to really be useful, a chunk has to be selected. So let me just grab any chunk. Let's grab like maybe this guy right here. Actually, let's get somebody that there you go. I just want to make sure that somebody we can see as being highlighted. So this yellow chunk here. Now, if you don't want a chunk to be able to be destroyed, you can switch off destroyable. That chunk will remain no matter what a player throws at it. If you want it to be able to be destroyed, obviously just leave this on. A support chunk is kind of like an integral piece which helps hold your fractured static mesh together. What it does is the fractured mesh will look down through all of the connected chunks, reaching all the way through the mesh, and it'll verify that it's connected to a support chunk. As soon as that connection is lost, the entire surface will fall off. Now, what does that mean to you? Well, I can actually demonstrate it probably easier than I can explain it. Let me jump into our level. And I died. So let me jump over here to another area. There we go. Now, earlier in the previous video, I set the bottom of this mesh up to be a support chunk. So if I saw off about a third of the way up the column, you'll notice the entire top falls down. That's because all of these chunks realized that they had lost connection to the support chunk, and so they immediately went dynamic, so to speak, and fell over. So that's how the support chunk system works. Now finally, you have spawn no physics. That means that if you were to destroy this chunk, it would just disappear. It wouldn't spawn a little physical copy of itself to bounce around the level. Now down from here we have chunk selection. This allows us several different things we can select. We could, say for instance, select the bottom like you saw us do earlier. We can select the top. We can grow that selection, we can shrink that selection, and we can click invert selection. So it's just little tools to help you select chunks more easily. Down from here we have several different viewing controls. Now these allow us to view individual chunks or certain groups of chunks just by moving some things around. So currently you'll notice that this is set to 48. If you're playing with this slider and you notice it's just not working for you, it's probably because you need to slice. What I'm going to do just to be on the safe side is just click slice again. And once that's done, now we have 45 total chunks, even though we told it 50. Actually, it says 46, excuse me. The viewing group has a slider to control which chunk you want to see, but it's 0 based. So in this case, we'll see 0 to 45. Now, as I slide this all the way up, as soon as I actually start sliding it, everything updates. Currently, the show mode is set to view only, so now it's showing chunk 0, then chunk 1, chunk 2, 3, 4, and so on. So you can slide through and look at each individual chunk. Now to really help drive that home, let me click off Show Cuts. So here we are just looking at individual pieces. We can show All But, which will show us everything but whichever one is selected within the slider. So as I slide up, you'll notice individual chunks are disappearing. Then we can switch that to View Up To. So now as we slide this down, more and more chunks will continue to disappear until we only have one chunk. It's just a way to help you kind of visualize the overall cutting. Now if you want to show everything again, just take view up to and just slide it all the way up. Now of course we have show cuts, which is pretty straightforward. Show cuts solid, which just makes those a little bit more solid, a little easier to see one chunk from another. Show visible cuts. This is just going to show you any cuts that are visible. And then finally we have slice color mode, which if I turn this on, currently this is set to random. If we set it to support chunks, it will color code any support chunk. So I guess I should set some of those. Let's click on select bottom, and I'll switch off destroyable, set those to support chunks. And then if we deselect, you'll notice the support chunks are now red. And if we show cut solid, then there you go. We can also set that to show destroyable chunks and any no physics chunks, which would be any chunks that are just going to disappear and not spawn a little physical copy of themselves. And finally, we have show core. Now, core is something I'm going to show a little bit separately. Just in essence, a core is a separate static mesh model that you can place in the center of your fractured static mesh just to help it look like it's got something holding it together. So, for instance, we could have a static mesh model of like a piece of steel in the center of this column, or maybe some steel rebar, or something like that to help it look like it's got some sort of support structure inside of it. That core will remain inside, so as the pieces break away, it'll expose the core. You can also have the cutting system take that core into account so that the pieces look like they would actually conform around that core. But that's something we'll talk about a little bit later. And that involves us actually using the core group to add a separate core and to remove it and so on. So that's all of the various settings for the fracture tool. Let's go ahead and just click on slice just to wrap this up. And now we can close the fracture tool window, we can close out of the static mesh editor, and we can close the content browser. However, do keep in mind that I have now made a change to our fractured static mesh. It's got a whole different slice pattern now, which does require that I rebuild lighting. So that's a quick walkthrough of all the settings for the fracture tool, and that will wrap things up for this video. Thanks a lot. Alright, let's talk about adding a core into a fractured static mesh. Now if I jump back into the content browser, I have a custom static mesh here that I imported from 3ds Max as an ASE file. So it's very simple. You just click import, and this is just a file you can save straight out of Max. The mesh itself is extremely simple. It's just a box. Matter of fact, if we open it up here inside the static mesh editor, you can see it's just a great big rectangle, and I stuck one of UDK's metal materials on it. The only other thing I did was to make sure I go into collision and add a 6DOP simplified collision, which really just puts a collision box around it. If I click on show collision, we can see that there. So this is what you need to have. You got to have some sort of a static mesh that you can place inside your fractured mesh. Now I'll go ahead and close this out. Now let's open up our fractured column, and we'll jump right back into the fracture tool. And we'll go ahead and kind of slide things around to make the most of our screen space here. I'm going to click on our column core, and then back in the fracture tool, I'm going to click add core. Now, the static mesh is actually inside. You can just make it out under the semi-transparent fracture mesh itself. We have a little translation widget down here. If I slide this out to the side, you can actually see that core. And really all you want to do at this point is just center this up. If you tap the space bar, you've got a rotation widget that you can play with, as well as a scale widget. So you can make all kinds of changes to get that core to line up exactly how you need it to. But in my case, the default settings are working pretty well. So with just that in place, we can click Accept Core, and it's going to reslice our mesh to take the core into account. Now that's pretty easy. Let's just go ahead and click Close. We can get out of the static mesh editor. We can close out of the content browser. I do need to rebuild all of my lighting, so we'll go ahead and click on that. We'll give Lightmask just a minute to get past all of that, and it takes just a moment. And as soon as that's done, we can close out the window and jump into our level, and you'll see something kind of interesting as we blow away pieces of our mesh now. So let's jump in. Now check this out. As we knock off pieces, we're now exposing the core underneath. Not to mention that you'll see that our pieces now have a flat inside. They're actually built taking the core into account. So it's a way that you can have a support structure inside your fractured static mesh. So that's really all I wanted to demonstrate, just a quick example of placing a core mesh inside of your fracture, just to make it a little more interesting so you're not just kind of obliterating something completely away. That's going to wrap things up for this video. Thanks a lot. Okay, now I want to take a look at some of the key properties that you can use to control your fractured static mesh. So I'm going to jump back into the content browser. We will double click on the fractured column, and I'm just going to take my static mesh editor and space a few things out to maximize our screen space a little bit. Now what I'm going to do is cover some of the key properties you're going to be using most frequently. Starting at the very top, you have your overall chance of physics chunk. With this set to 1, every time you shoot a chunk inside the level, there's a 100% chance that that chunk is going to get a physical copy that bounces around the level. As you start to pull this down, you get a lower and lower probability of that, meaning that some of the chunks will just start to disappear as opposed to firing off some sort of a dynamic version. Now, down from here, we have chunk angular velocity, or chunk angvel. This is how much spin is going to be applied to a chunk as it flies away. We have its linear, horizontal scale, and linear velocity. Linear velocity is how fast it's going to fly away when it's broken off. Now, a chunk will fly away in the direction of the overall surface normal of the mesh. Meaning if you break off a chunk on the left-hand side and it's pretty much a flat left-hand direction, it's going to fly off perpendicularly to that surface. So you can increase that speed here. You also have a horizontal scale. Increasing this means that your chunk is going to tend to fly out horizontally more than vertically. Very useful if you kind of want to get that almost ring-like explosion. Next, we have composite chunks explode on impact. If we were to take this fractured mesh and kind of saw it off halfway through, the top half will come crashing down and then fall over. If you'd rather that top half to hit the ground and crumble, just switch this on. Solves that problem. Now, moving down from here, our next key area of interest are the explosion settings. These allow you to control what's going to happen to the fractured static mesh if it's influenced by an explosion, such as a vehicle exploding or anything else that causes an actual forceful explosion in your game. So if an explosion hits it, what's the chances it's going to spawn a physics chunk for each piece? The overall scale max and scale min, so you can actually resize the physics chunks that come out based on whether they're hit by an explosion. So if an explosion hits, you want it to have much smaller pieces, like tinier debris. You can change that here, and there's a random value here, so you can choose a min and a max. It'll pick a value in between. You can also increase the velocity of your physics chunks by, it's kind of like a multiplier here. With a default of 1, that means they're going to pop out at their normal speed. But if an explosion hits, you want them to move a little faster, you can increase your explosion velocity scale. Fixed isolated chunks will more or less override the effect of using support chunks. This means if we were to, again, saw our column in half, if this were active, the upper chunks wouldn't go anywhere. They'd be fixed, stuck in place. Now, just kind of moving down from here, we have a fragment destroy effect scale and a fragment destroy effect. We can add something to this by clicking the add new item button, and what this will store is a particle system. So if you want to get like a little explosive particle system, you can plug it in here, and then as you break pieces off, that explosion will spawn right there in that location. So you can add, smoke flying off or sparks or anything like that. And then you have an effect scale if maybe the explosion you're using was actually intended to blow up a vehicle, and when it blows up chunks of your mesh, it's a little oversized. You can scale things back right here. Now I'm going to go ahead and nuke that out. Now we have fragment health scale. As you increase this, fragments will become harder to break off. As you decrease it, they're going to become easier to break off. By default, they're already pretty easy, though. You can also do a max and min health. Now, by default, the way this works is that larger pieces have more health and smaller pieces have less health. So you can kind of influence that relationship here. Now, as we scroll down from here, another key area is LOD info. Now, this is critical. In fact, we're going to change this right now. LOD info is always there with a static mesh. It allows you to control the material applied to a static mesh, and by default, it's always got one element. Currently, this has a couple of elements. In fact, it's got an extra one down here at the very bottom that we're not actually going to be using, but you'll generally see element 0, which is your basic static mesh, and element 1, which is your internal material. So as we were breaking off pieces of this mesh and you were seeing that blue and white checker null material, this is why. It's because currently this material was set to none. What I'm going to do is expand element 0, grab the cement block material applied to the outside of our mesh, hit Control C, and paste this with Control V into the slot 1 material as well. That means the inside of our mesh will also have a concrete material, but you could set it to something else. If you wanted to make maybe a custom material that looked a little hot or molten, you could make use of that. Now, let's kind of slide down from here. We've got a couple of other things. We have normal, physics chunk, scale, max, and min. Now, by normal, what they mean is when a physics chunk breaks off from something other than an explosion, such as gunfire. You can give a random value here if you want your physics chunks to come off at different sizes. As we kind of move down from here, you can slice using core collision. This is on by default, and this means that since we put a core in there, you'll get a nice change in your shape to kind of make way for the core. Whether or not you want physics chunks to be spawned, if you switch this off, you won't actually get those individually reactive physics chunks. Your pieces will just appear to just vanish, really. Down from here, we have uniform fragment health. This completely does away with the large chunks getting more health than smaller chunks. Everybody now has the same health if you switch this on. And really, these are the big values, the ones that you're going to be using more often than not. So let's go ahead and close this out, and I'm going to go ahead and immediately click on Rebuild Lighting, and as soon as I've done this, this will take any changes such as the internal material. It'll go ahead and get those applied so that now, when we jump into the level and blow off pieces of the fractured static mesh, we should see that they no longer have the null material inside. So let's jump inside real quick and take a look at this. And as I blow these off, notice we have a nice material on the inside now. So there is a quick look at putting together your own fractured static meshes and adjusting their properties accordingly. that is going to wrap things up for this video. Thanks a lot.
We'll be right back.